Right, good morning and Happy New Year. Not that it's really that important, right? The Earth has just, went around the sun another round. Yeah, just another time is not a big deal.
By now it's
sorry?
By now it's another time.
Yep.
We're like a quarter second off this year.
Yep. But then there's Chinese New Year or Lunar New Year, so there's another New Year to celebrate. So I'm going to get started with the class. People will still be coming in for a while, I suppose. How's parking today?
Not bad.
Not good? Even with the parking structure, it's not good?
No, I had to look all the way up on the far side of the last section of parking out there because that's how crazy it was at 9 a.m.
Wow.
I got staff.
Okay.
I always park in the back.
Yeah, you can put a trash can to prop up the door because the door will lock by itself.
Still haven't gotten that key fixed.
There won't be any replacement of those keys anymore. Because the locks of these doors is so old, they don't make those keys anymore. So first thing first, some of you, most of you, know that I don't use D2L, so I'm using Moodle, and some of you have not taken a class from me in the past 2 years or so. The URL has changed. It's no longer some profs. It is now moodle.losrios.edu. Yes, we have been assimilated.
Do you still maintain it?
Huh? I still maintain it.
Okay.
It's just that the infrastructure is now supported by a district, which is not as, it's actually better than most people think. I have an uptime of 360 something days, so I'm calling it good. Okay, so for those of you who are currently enrolled in this class, you can just go ahead and log in. All of the notes, homework, and stuff like that, all the resources will be here. The other place you also want to check out will be YouTube. So if you go to YouTube/someprofs, and I didn't change this one, it's the channel for a few classes. It's not just for this class, it's actually for a few classes. I try to record every single class. Occasionally I have technical difficulties, or I forget to bring my gear, or for whatever reason I cannot record. So don't really 100% count on it, okay, the recording. Write notes, just to make sure that you get, all the content in the class. But for the most part, I do, record my classes. So once you get to my channel, go to videos, which is the second item on the tabs here, and it will list all the classes in reversed chronological order, which means the most recent one will be posted first. Now this is our first class, so there are no cisp440 entries just yet. Okay, but after today, after this class, I'll be uploading today's lecture, and it will be the first item for a little bit of time, because I'm sharing this channel with a few other professors, so you will see other classes too. It's no big deal, because when I upload stuff, it's always with the class code, which is cisp440 here. Are there any questions about how to get to YouTube to find the video recording of this class? Because that's the one part that the video recording itself is not going to help, right? It's kind of recursive with no end to it. All right, so I'm going to log in and show you your syllabus. I have gotten too used to my gaming keyboard, with these kind of squishy keyboard. Sometimes it takes like a few
You finally upgraded from the point stick keyboard.
Yeah, I finally upgraded. I don't even play games with my quote-unquote gaming keyboard. It just types a lot faster on those things. All right, so this is cisp440. There are still like an entire row of seats up here. If you want to sit down, there are more seats available. All right. Okay, first thing first. Okay, do you want me to go through the syllabus first or the prerequisite first? I can use either one. The prerequisite. Okay, the prerequisite of this class is CISP 360, which is C and C++, and Math 370, which is pre-calculus. Okay, so as I went through the prerequisite checker online, I noticed that a few people do not have not met both requirements. So you might want to check what you're getting in the score for Prerequisite Checker. It's not really a homework assignment. It looks like one, but it's not. It's just a easy way for me to indicate whether you have met all the requirements for prerequisite for this class. So you might want to double check, because if you are not getting 2 out of 2 points, then you want to kind of get it handled. Basically challenge the prerequisite of this class. The majority of the class is okay, but a few people are missing one or the other. All right, so the syllabus is no longer just a PDF document. I turn it into a quiz, and some people have done it already. So we'll just go ahead to take a look at the syllabus. So the syllabus looks like a quiz. It's not really a quiz. It does not count to your final grade. Okay, so you can take as many attempts as you want also. Okay, but at some point I'm going to go through what you guys turn in, and basically say, okay, these people have acknowledged that they know where the syllabus is and have found it, and they can stay in the class. The section information here is just a copy and paste from the schedule. So this is discrete structure for computer science. The class has changed from when Professor Fox was teaching it. The change was mostly to make this class align with CID. Does anyone know what is CID? No? Okay. Does anyone know what is going on with your transfer degree?
It has to make it align with Davis's requirements for, I think, transfer, right?
Right. Well, the entire California now has one single standard. So community colleges, CSUs, and UCs are supposed to agree on the same, transfer class descriptions. So the class here has changed. So the topics have been rearranged a little bit to meet the same requirements. So some topics are removed and some topics are introduced into this version of cisp440. And as you can see here, the prerequisite of this class is cisp360 and Math 370, which is pre-calculus. If you have not met one or both of these requirements, you need to file a prerequisite challenge form, and in about 2 weeks of time, I'll check again to make sure that everybody in this class has met all the prerequisites. Many of you have not taken Math 370, but you have taken more advanced calculus classes, and that counts too. So I have already indirectly checked the prerequisites. Okay, so don't worry if you have not taken 370, but you have taken a few calculus classes already. The co-requisite of this class is cisp430, which is data structure. How many people are taking cisp430 this semester or have taken that class already? All right, so basically everybody. I think it will be helpful, okay, if you have taken it already or are taking it, in the same semester, because when we get to proof by induction, it will remind you of recursion, because those two things are very related. All right. This course is transferable to UC and CSU. I think they're still trying to get Berkeley to sign on to the whole CID idea, because Berkeley is not playing.
You're not your own leaders at Berkeley.
Well, they always want to be kind of
They're special.
special, yes. All right, so full-term class. So this is the question that you have to answer. Is this the right section? Are you supposed to be here in cisp440? If you're in the wrong class or wrong section, it's time to drop the class. So it gives you a chance to answer this question. Select one. This is the correct class and correct section. I intend to stay in this class. Click. Moving on. So the second question, so basically it looks like a quiz, but it's really just a syllabus, but it does require you to click on things and submit it, just so that I can say that, yes, I make sure that everybody has access to the syllabus and has read the material. And I know most of you are just going to look for, I acknowledge and click, and not really read anything in between. But on paper, at least I know that you have interactively done this part. So the instructor of this class is me. I am Tag, last name is Aoyang. This is a hyperlink to a Wikipedia of my last name. So for anyone who wants to, dig that up, I have already dug it up for you. The email address is drtak2015spring@gmail.com. I use one new email account per semester because this is an easy way for me to keep track of all the email messages from students as opposed to from the school and other stuff that use my ARC account. The phone number is 916-484-8250. If you leave a message, it will send me an email with the attachment of the voice. So that part is kind of cool. Office is number 7 in Liberal Arts 133, which is one aisle on that side. And the office hours are easy to remember. Every single day from Monday to Friday from 8 o'clock to 9 o'clock a.m. Are there any questions? If you need to arrange for another time to talk to me, you can let me know. And I'm in my office a lot, so I can usually arrange another time to talk to you if that is not a good time. Recharging, yes. In suspended. Okay. So click. First day of class or orientation. Any absence of the first day of class, which is today, or orientation is sufficient reason to get dropped. Be sure to attend the first class or orientation of your classes. Unless you are watching this on YouTube and not physically here, you're fine. I'm just kidding. I'm pretty sure most people who want to take this class are physically here and not just waiting until the video is online. Excessive absence. Now this part is kind of important too. Los Rios regulation defines, cruel. No, that's singular. Cruel, okay. Define excessive absence as 6% or more absences. Any absences in excess of 6% is sufficient reason to get dropped from a class. So this is not my regulation. If you click on the link here, it will bring you to the legal document of the Los Rios district. So just so that you know where to find the reference material. In a face-to-face class, which is this one, I hope I won't forget to actually use it today, because I usually forget. It's the row sheet.
3 weeks you'll forget it.
I need a little reminder thing, right? So in a class like this, I typically just use a row sheet. You just have to initial your name, next to your role, and I call that good, okay? And I usually do it maybe about 15, half an hour into the class if I remember to do it. Most of the time I forget to do it, just. I might give you some pop quizzes too from time to time, something like just one quick question, that would take you 5-10 minutes to answer, and I can indirectly use that to take roll as well. So in a class like this, for what is considered excessive is based on this calculation. This is a 54-hour full semester class. Okay, if you look up the schedule, it says we are supposed to meet for 54 hours. Each class session has 80 minutes. So when you divide 80 by the number of minutes in one semester, one session is about 2.47% of the entire semester. So the first absence is 2.47%. The second absence will bump it up to about 5%, which is still under 6%. The third absence is going to bump it over the 6% and will be considered excessive. So are there any questions about that? You can have up to 2 unexcused absences in the entire semester. The third one will bump it over and become excessive. All right? It's not an online class, we can skip that part. Unexpected things, do happen in life. It happens to me, happens to everybody, and that's what the 6% is really for. It's not for habitual absences, okay, or for people who cannot wake up in the morning just because they cannot wake up in the morning. And I know people like that. My own daughter is like that.
Your daughter's like the 8.
Yeah. So click here. I understand the excessive absence policy, and I will make sure my absences stay less than 6% to stay enrolled in this class. Certain absences are excused. There are 3 types. The first one is a health-related absence. A student's own health-related absences are excused, but only with a doctor's note or some alternative evidence deemed acceptable by the instructor. The nurse's office, they call it the health center. Okay, over at which building? Administrative building. They can give you a note. Okay, if you feel that you're not really feeling well, you know, when you're on campus, you can go to the health center, and you know the nurse can write you a note and say, okay, this student is sick, you know, is not fit to go to class, and so on. Okay. If you're in the military and active, and you need to do things, and you need to, you'll be absent in a few classes, that's okay. You know, just give me a copy of your notice, and you know that'll be fine. You can cross out stuff too, you know, before you give it to me, like photocopy, and then just cross out all the important information. I don't need to know all the details. I just need to have your name on it and the date. That's all. Same thing with jury duty. Okay, if you're on jury duty during the semester, you know that can be excused as well. Now, jury duty is kind of a tricky thing, because if you're on in a jury and it takes a long time for the trial, even if your absences are excused, you know, missing too many classes is not going to be good. Is anyone scheduled to be on jury duty during this semester? Okay. Do you kind of know?
I think I'll get canceled though.
Sorry?
I think I'm getting canceled.
Okay. You can only move it once. So if you are planning to postpone it, they will only let you postpone it once. And then once you postpone it, the next time, you know, the judge won't let you get away with it anymore. So you might want to set a date or set a range of dates where you can actually serve jury duty. Okay. I know that stuff because I got into it. All right, click this. I understand only the listed type of absences are excused. Academic dishonesty. I used to have a much longer slide than this, but this time I'm just going to simplify a little bit. So this is how dishonesty is defined. Academic dishonesty occurs when the student or participate in any activity to attempt to show possession of a level of competency, knowledge, or skill that the student or some other students do not possess. So basically participating in any type of activity to make someone or the student himself or herself look like, you know, that person knows more and can do more than actual. And on the flip side, we can also define academic integrity, which is the opposite of that. So this is a slightly more positive way to define it. So in this case, the grade of a particular assessment of a particular student reflects the academic performance of the student and only of the student who turned in the assessment at the time of the assessment, following all the rules of the assessment, as well as general rules already discussed in the syllabus unless otherwise stated, and using only resources that are permitted by the instructor. For those of you who have taken classes from me, you know that most of my tests, or all of my exams, are open book and open notes. So, and it will be the same for this class. Open book, open notes, on paper only, okay? No electronic devices during the exam, okay? Now, knowing that, I hope that you guys will be taking notes in a way to help you in exams, because that's where your notes will come in handy, because even though everything is recorded on YouTube, you cannot access the YouTube videos during the exam. I used to have online tests where people actually do that, like halfway through an exam online, they will go watch like a little clip of my videos, and I can tell you that's not really an efficient use of time either. All right, so select A, I understand and agree to the broad definition of academic honesty and integrity.
Don't forget the time that you did allow people to use their computers. Someone posted the answers to script D to your test. Remember that? It happened during our final.
That's for CIFC 310.
Yeah.
Yep. Well, it's not going to be able to happen here because you know it's not based on the test bank, so it won't work. Student rights and responsibility is not specific to this class at all. You might want to read it. How many people have read the Guide to Student Rights and Responsibilities? Shocking. Shocking. Okay? That really is a very important document for you to read because it doesn't just define what your responsibilities are, because most people don't want to read about responsibilities, but it also tells you what your rights are as students. Okay? If you're not happy about something, how do you let people know about it? How do you file a grievance? And so on and so forth. So it is a very important document for all of you to read.
It's not very long.
Sorry?
It's not very long.
It's not very long, but it's a good document to read just to know the responsibilities and so on. Classroom behavior and expectations. A classroom, virtual or otherwise, typo, is a place to teach and learn. Disruptive behavior in the classroom will not be tolerated. Repetition or continued disruption behavior, despite warning, is sufficient ground for disciplinary action as per the Guide to Student Rights and Responsibilities, which is in the previous slide, right? I'm not really strict like some other professors, but so once or twice is not a big deal, but if something keeps happening, even though I said, okay, please stop that, that becomes an issue. Chatting happens occasionally, okay, just because sometimes you might have a question that you want to ask your neighbor, okay. So if it's not too much, it's okay, but if it disrupts other students, then it becomes an issue. If you have a question about the material in the class, go ahead and ask me instead. I'm hoping that none of you have seen me like not answer a particular question from anyone in class. Has anyone observed that? Nope. Okay, so if you have a question about class-related material, go ahead, raise your hand, and I'll try to answer your question as soon as possible. Sometimes I don't answer it right away because I have some more material to cover, and then I'll open up and say, okay, you'll go ahead and ask the questions. If you need to borrow a stationary item from a student next to you, that's fine, okay, not a big deal. Interrupting. If you have a question, go ahead and raise your hand, and then I can address you and say, okay, go ahead and ask the question. Specifically, this happens a lot, the quote-unquote interrupting happens when multiple people have questions, and sometimes, they just want to ask the question right away and not, wait until, the other student is done asking. Or sometimes they're too eager to answer the question of another student, which is a good thing. Mobile devices, please turn off or silence your mobile devices. If you need to talk, it's okay. You just have to do it outside of the classroom. And I forgot to turn off the ringer. So I'm going to have to turn it off now.
Where's your hand?
Well, I updated to Cyanogen mod 12, so all the settings are gone. I have to reprogram it. Do not eat or drink in the classroom. In this classroom, it has a sign that says no food, drinks, phones, or kids. I'm not sure about the last part, but it does say that no food or drink or phones. In a classroom like this, since you don't have any computer or you don't have a computer that belongs to the Lost Real District in front of you, if you want to drink plain water, it's going to be okay. Okay, so if you have a laptop computer and you're drinking and you spill on your own computer, I won't be responsible. But plain water is okay in this classroom. Come to class on time. Okay, walking in late distracts the class, and it really shows in the recording too. When the door closes, there's a big pop in the recording, in the audio of the recording. If there's a class prior to this one, let everybody from the previous class out of the classroom first. And I think there is a class before this one because I just kind of looked at the door chart and there's another class. Questions are welcome as long as they are related to the class or they're asked in an orderly fashion. If you don't understand something that I talk about in class, make sure that you raise your hand right away and I will address your question as soon as I can. I think that's an alarm from next door. Okay, how to attend lectures. I'm not going to go through read all of this stuff to you. Just basically, it says that I'm recording most of my classes, but there's no guarantee because sometimes there will be technical difficulties or I forget to do certain things, like pressing the Enter key after typing in the command line. Sometimes I do that. I would type out the entire thing, and then I would just go. I will wait until the right time to press the Enter key, and then I will forget about pressing the Enter key. So at the end of the class, there won't be any recordings, right? So don't count on it 100%. Make sure that you write your own notes. Yep.
That reminds me, did you make sure that it's recording through the microphone?
Yes, I think so. So, that's good. Good to check occasionally. Let's see. That being said, the most important part of the lecture is not trying to copy everything that I do or say or write or draw or anything like that. Your focus is on understanding the material. Okay, that really is the most important part. I think you guys are pretty lucky, because now you have, we have screen recording, we have audio recording. If you want to use your cell phone, just to be sure to do your independent audio recording, that's fine with me. It doesn't bother me at all. Plus, all the material that I'll be using will be posted on the website already. Okay, so there's nothing really new other than stuff that I type in class, which I will type, on the screen as well. So there will be very little stuff that I do on the whiteboard. Try to read ahead of me on the lectures. In other words, I'll show you guys, all the links, later on. So all the links on Moodle are useful, and I usually go sequentially, unless I find a reason to reorder the topics a little bit. So you can usually read ahead of me and be ready for the next lecture before it happens. That really is helpful sometimes. So, like this one. Moving on, grading policy. I actually expanded this section quite a bit because I really want to define, what is A, B, C, D, F in a class. If you look up most of the references on the internet, A, B, C, D, F would be defined this way. A, which is a GPA of 4.0, means excellent. The next one, B, means good. The next one is C, which means satisfactory/fair. And D is usually considered passing, but it's a low passing grade. And F is a failing grade. So that really doesn't tell you a whole lot about, what do you need to do to get a particular grade. So I expanded this a little bit. F is an easy one. It's a failing grade. There's no demonstration or insignificant demonstration of any proficiency. And at work, which I'm hoping most of you are striving for at some point, is anyone taking classes just because they want to take the class and not really have any plan to get a job that is related to computer science?
At some point or another, yeah.
Okay, well, but that's that's your objective, right? Eventually you want to get a job. So at work, what an F translates to is delivering nothing or nearly nothing or something that is negative. Okay. Unfortunately, there are certain places where some people, employees, are better off not going to work because when they go to work, they do more damage than good. I'm not kidding, by the way. People who get an F, quote unquote F at work, is likely to get a pink slip, getting fired, a written complaint, or a lawsuit. Okay, what is a D? A D is technically a passing grade, but it is not sufficient to fulfill a prerequisite of another class. That really doesn't apply to this class, does it? Which class has this class as a prerequisite? 0. This is it. Okay, this is it has no dependency, at least not at ARC, right? But this is what a D is. A D is there is some demonstration of knowledge or understanding, but not enough to meet a quote unquote reasonable expectation. At work, this translates to delivering products that is unacceptable to a boss or a customer, and usually you will be that person will be asked for a refund or redo. In that case, it's okay. It's basically not acceptable. A C is basically just okay. On paper, it is satisfactory, but there are 2 grades better than a C. So one way to look at this is it is just considered okay. At work, this is just barely acceptable, so it's just, so people won't be asking for a refund or a redo, but it's just barely meeting that minimum expectation. A B is submitting work of assessment that meets or exceeds expectations, but it can be better. Okay, this reminds me of a video. There was a kid on YouTube, who was imitating Chinese parents. So the kid was pretending to be both the kid himself and his dad, and they were driving, and the kid was reporting his grades, right? So the dad asked, okay, so what did you get in chemistry or whatever? The kid said, well, I got an A in that class, and then the dad go like, can be better. And you can imagine what happened when the kid said, I got a B in something, and then just, you can watch it on YouTube, it's really funny. At work, what a B translates to is delivering products that a boss or customer will gladly accept despite, some room for improvement. So it's not perfect, but it's definitely, above expectation. And an A is easy to explain. It's just perfect, okay? So not much room or no room to be improved, at least according to the assessment itself. And just to make sure that you understand the whole concept of A, B, C, D, F, I have another explanation here. So imagine that you just got a hard drive from Fry's, okay? So how would you grade that particular hard drive? And F means you install the hard drive, it does not work, and it takes everything down with it. The power supply smoked, the motherboard smoked, it's just that, and the fire department had to show up. So that would be an F. A D means you install the hard drive, it is noisy and a lot of vibration, and it failed way before the MTBF, mean time between failure. Okay, so that would be a D because it does work, okay, for a little while. A C means you install the drive and has the average amount of noise and vibration. Okay, it's typical. The average of all the installed drive will fail at the rated MTBF. So it's no worse than and no better than the advertised mean time between failure. A B means you install the drive, it is quiet and with less than average vibration. And the average of all the installed drive fail after the rated MTBF. But that's just the average. So if you look at one individual drive, it can still happen before the mean time between failure. And A means you install the drive, you are surprised by how quiet and stable it is. And not a single drive installed failed before the MTBF. So are there any questions about what A, B, C, D, F mean in a class? So that is sufficiently explained? Okay, very good. So in a class like this, okay, I'm not going to go through this because I think we're beating a dead horse, right? We're in fact chopping up and grinding it right now. So I'll just kind of skip to the last part here. The last part is how do you translate the score that you get in a class to the letter grade that you receive at the end of this class. It's just A, B, C, D, F is just rated like this. So in my class, an F is going to center around 0%, a D centers around 25%, a C centers around 50%, and a B centers around 75%, and A centers around 100%. So the boundaries or the thresholds to get a grade will be 12.5% to get a D, 37.5% to get a C, 62.5% to get a B, and 87.5% to get an A. So for those of you who have taken classes from me before, it's the same as before. I'll just explain it a little bit differently.
The most forgiving grade scale ever.
Sorry?
I said it's the most forgiving grade scale ever, or so it seems.
Yeah, so it seems. Yeah, so it seems. I like that qualification. Assessment activities, that has not really changed either. Assignments will make up 20% of your final grade, and you really want to read all the details here, no late policy and so on and so forth. The first exam is 20%, second exam is 20%, and the final exam is 40%. So that makes up 100% of your final grade. So here we go. Any questions about how your grade is chopped up in the semester? Okay, questions? The schedule, this is the tentative schedule. Okay, sometimes I move things around a little bit, stretch out some and shrink the other ones. And then the final exam is on Thursday, May 14th. So you might want to put it on the calendar right away so that you don't forget. So click that. So click next. And if I want to turn it in, I can just submit all and finish. I should be getting 100%. So you can basically know how many points you're getting out of it using your gradebook. Now this part is important because if you don't get through this part, you won't be accessing the notes because everything else is conditionally released. So it doesn't work for me because I'm not logging in as a student. All right, so we'll go ahead and start the class. And since I still remember the roll sheet. Right. So why are you in this class? Other than the obvious, like, I want to transfer to blah, 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 and it's on the list. Sorry? Okay, okay, let me ask you a more direct question. What does math have anything to do with programming? Go ahead.
Programming is a set of math functions that basically runs everything.
Okay, that's good. Yep, go ahead.
For algorithms and efficiency.
Efficiency in algorithm optimization. Okay, optimization is good. Making your program work faster is always good. There was a hand back there. Oh, different question. Oh, different question? Just on the student. Can I answer your question now?
Yeah, I was wondering how necessary is the book?
There's no book for this class. I just use my own notes here. So I will prepare notes for this class. If you want to get a textbook, I can look up and see if there are any good textbooks. So you can use it as a reference material.
The one that you recommend on your syllabus accounting that
The syllabus?
I think I saw a textbook there.
No, there's no textbook recommendation. All right. Anything else? Any other reasons why you're here taking this class?
Requirement.
It's a requirement. Okay. So any other answers about why math is related to programming? No, no other. Go ahead.
We need to prove our program is working 100%.
Verification. Okay, that is a good idea. Okay. So how do you know your program is working the way it is supposed to? Okay. That is actually two questions rolled into one. Because the first question is, how do you express, how do you state this is what the program is supposed to do? Just that is already kind of difficult. Okay? The next one is, how do I know this program meets that particular requirement? And that's basically a series of proof steps to prove that your program is working 100% all the time. Okay. So what we'll do is I'm just going to go through this a little bit. Truth and false. What is that? So the question is, you want the truth? You can't handle the truth. Can we handle the truth?
Maybe.
Well, so the first question is, what is true and what is false? Okay, in the context of programming and in math. Okay, what is true and what is false?
Any non-zero value is true.
Well, at the core of this class is, we'll talk about true and false a lot in this class. Okay, in fact, most of the time we'll be talking about that until we get to statistics. Then it's like, that's kind of fuzzy. It's kind of gray. Okay, so if you look up a dictionary, truth is defined to be the quality or state of being true. So you need to look up what is true, and true is saying in accordance with fact or reality, accurate or exact. But in this class, guess what? We are not really too concerned about in accordance with reality. This part is not too important to us. We are much more concerned about in accordance with certain types of rules that we have set up in mathematics and also in programming. Okay? Now, programming is 100% related to mathematics because who came up with computer science?
Mathematicians.
is a mathematician or mathematicians, okay? But when you look at modern computer science, who is considered the father of computer science?
Alan Turing.
Not Steve Jobs or Bill Gates or Steve Ballmer. He looks like a father to me. Okay, so who's the father of computer science? Turing, Alan Turing. Okay, has anyone watched that movie? And the Imitation Game? Okay, no? Okay. That's a movie based on the true facts of Alan Turing, dramatized, okay, but it's based on facts, okay, based on his story. And he was a mathematician, okay? And if you want to describe Alan Turing, besides being a mathematician or computer scientist, what word from modern vocabulary would pop up? He's a hacker. He's a hacker, okay? And what did he hack? The Enigma machine, okay? So that's Alan Turing. He was using computers to break the code used by the Germans. Yep. But getting back to this note here, this is why I pop up my notes here. It kind of keeps me on topic. So truth is, is there class today? That's a question, okay? So instead of looking at conditions as a question, it's also okay to look at it as a statement. So instead of looking at it as a question, we'll look at a statement. There is class today. Well, when we normally say there is class today, it is an assertion, which means there really is class today. But in programming, when we look at there is class today, it is called a statement. It can be true, there really is class today, or it can be false. No, there's no class today. So we look at this as a statement, and then we can qualify and say this statement is true or this statement is false. We have logical operators from cisp 360. We know a few logical operators like AND, conjunction, or disjunction, and NOT, which is negation. But now I know everything there is to know about Boolean and logical operations, right? Because there are only 3 operators. Of the 3, we only need 2. Okay. Do you guys understand what I just said? Of the 3 common logical operators, negation, conjunction, and disjunction, we really only need 2 of them.
And
Well, the negation is important, so we have to have negation. Then you can pick one of the 2. Okay, you can pick conjunction, or you can pick disjunction, because there are ways to reverse or to convert a conjunction into a disjunction with negation. Okay. You guys want to do that? Just as a quick exercise, a little warm up for the rest of this semester.
Let's do it.
Let's do it. Go ahead.
I can think of an example right now.
Okay.
Let's say you have an integer I and you set it equal to 1. And then you do a check. You do one of 2 checks. The conjunction check, which is I equals to 1, or another check, which might say is I not equal to 2 or I not equal to 0, for example.
Okay, but I equals 1 is not a conjunction.
Does it count?
Nope, it's not a conjunction. Conjunction means you use and, or in C++ it is ampersand, ampersand. All right, so we'll go ahead and take a quick look here, because it's a good example to look at. All right, so we are now looking at the expression A and B as a Boolean expression. And I will say, okay, you cannot use and, you can only use or and not. How do we express exactly the same thing? The first step is to say, okay, I can use double negation. Are there any questions about this equivalence? The negation of something is the original thing, okay? It doesn't change the meaning at all. Is that part okay? Okay. If that part is okay, then we can look at this and say, can we do something about the negation of a conjunction? Has anyone heard of the name De Morgan's law? And we can apply De Morgan's law here. Now, De Morgan's law is really interesting because it works in both directions. It can convert the negation of a conjunction into disjunctions of negations, and also vice versa, it can apply to the other one.
Can you repeat that?
I cannot, but I can show. I can write it out. I can write it out. Okay. So in this case, we are trying to convert the negation of a conjunction into the disjunction of negations. Okay. I'm not going to repeat it. I'm just actually going to write it out. Okay. So we'll say it is the same thing as blah blah or blah blah, and each one is a negation.
Not A or not B.
There we go.
Which is now equal to disjunction.
So now conjunction is gone, right? We have just converted conjunction A and B into, well, a few negations. It is the negation of the disjunction of the negation of A and the negation of B. And that's why, natural language is not really suitable for a class like this, because, we don't use parentheses in, normal, conversation. How many people think this is all baloney?
I don't,
Yes, go ahead.
Maybe, but so not A or not B is the same thing as A and B. Is what you're saying so far?
Not A or not B
is
is the same thing as A and B.
Yes.
Okay, can we prove it?
Sure.
How do we prove something like this? Truth table, okay? The truth table is really, really handy when we deal with logic and Boolean algebra, because we can enumerate all possible cases, right? What can be on the left-hand side of an and? What type is it? Is it an integer, a floating point number?
Boolean.
Is a Boolean. Now that question was not well formed, because coming from CISP 360, you know that anything that can be 0 or non-zero can be used on either side of a conjunction. But logically speaking, it can only be true, false. Okay. All right. So what we'll do is we'll use a truth table to prove whether this is right or not. And by the way, when I claim something like this, and you say, I'm not really sure, you can always say, tag, I'm not convinced, prove it to me. And you should probably do the same thing with all of your other classes. Okay. Now A and B, or A, B, are independent variables. In other words, the value of A is not influenced by the value of B, and also the other way around. So that means the value of A can be true or false, independent of the value of B being true or false. That will give us how many rows, how many combinations of values of A and B? 4 rows. Okay. So in this class, I will probably try to stick with one or the other. So I would use 0 to mean false and 1 to mean true. Okay. So now we have the 4 possible combinations. Okay. So when A is false, B is false, what is the conjunction of A and B? False. It's a false. Okay. Now this one looks a little bit more nasty. So we'll work on this step by step. A is false, not A is true. B is false, not B is true. True and true is true. Not true is false. Okay. So a long way to get to this false here. Next row. A is false, B is true.
False.
That is false. Okay. So in this case, not A is true, not B is false. What is true or false?
False.
Is no. True or false is true. Okay. So this part is true. Not true is false. Okay. Next row is symmetric. Okay. So we'll just gonna go through this real quick, because both conjunction and disjunction are. How do you call something where you can flip the order? Commutative. Okay, so you can change the order. Okay. So last row is the one that is left. Okay. A is true, B is true. What is the conjunction of those? True. Now let's take a look at this one. Okay, A is true, not A is false. B is true, not B is false. False or false is false, not false is true. All right. Okay, so now that we have a truth table, which part tells me that A and B as an expression is the same thing as the De Morgan's conversion of this?
The false statement, the first false statement, the last true statement.
For every single row, okay, the value of A and B is the same as the value of the expression in question. So this means no matter how weird it looks, if you can establish the columns have exactly the same values, the expressions are equivalent. Yep.
Is this a coincidence, or is there like a proof that really shows how they are equivalent? I mean, the truth table, it looks equivalent to the truth table, but it doesn't feel right. You know what I mean? It looks kind of weird.
It has to do with this. Okay. This has to do with how we define or and how we define not. Now this part here, if you just look at the first three columns, that's the definition of conjunction, right? How do we define disjunction? I'm just going to be lazy here and just cut out certain parts that we don't need. And we'll answer each question here. So by definition, what is false or false?
False.
False. What is false or true? True. True or false is true. True and true is true. And the last one is negation. So A can be 0 or 1, true, or false or true. Not A is the negation of that. Not false is true. Not true is false. So the definitions of conjunction, disjunction, and negation makes De Morgan's law possible. So it's not so much, De Morgan's law, exists to do something. It's basically an observation that based on how disjunction and conjunction are defined, and also negation, that just kind of works out. Yep.
So, if the conjunction is false, then the double negation of the disjunction is also false.
Yes. But it has to, in order for two expressions to be equivalent, they have to be exactly the same on every single row of a truth table. Cannot be just some of them, it has to be all of them. Okay. Are there any questions about De Morgan's law?
Can you show us with and instead
Yep.
of it being A, B, A, and B?
Absolutely. Okay, remember earlier I said, it also works out the other way. So in this case, we have a OR here, and I claim that we can put an AND here. Now obviously the rows will not have exactly the same value, so I'm going to delete all of these and work it out from scratch. There we go. The third column is not a problem. The third column, because it's just the definition of disjunction, false or false is false. That's a 1, that's a 1, and that's a 1. That's by definition. That has to do with the definition of disjunction itself. Okay, hold on a second here. Who defines disjunction and conjunction? How do we know that true and true is supposed to be true? Or true or false is supposed to be true? Why is it like that? It has to do with what? How we use the word or in just normal conversation. Right? Does that make sense?
Yeah.
Yep. And the same thing goes for and as well. Okay, the word and, A-N-D, in English is defined like that. That's how we use those words. Now in this case, let's work this out. Okay, A is false, not A is true. B is false, not B is true. True and true is true, not true is false. So the first row has a match. Let's work out the second row. The second row has A being false. Not A is true. B is false. B is true, not B is false. And this time we have true and false is false, not false is true. And because both conjunction and disjunction are commutative, this one is going to be the same. So now we only have one row left to do. Okay? We have true and true in this case. Not true is false. Not true is false. False and false is false. No, false and false is false.
Not false.
Not false is true. And if you look at the third column and the fourth column, they match up exactly. And that's why we can establish A or B as an expression is equivalent to the other longer and messier one. Yep.
It almost looks like that if you compare the last column of the last thing we went over with the last column of the first thing we went over, like it looks almost inverse if you flip it around.
Kind of, yeah. Right. So with this out of the way, but let me just kind of go back here. Are there any other questions related to De Morgan's law? Why do you think De Morgan's law is important? Is there anyone here who is planning to go to a computer engineering or electrical engineering program? Okay. And why do you think this is actually useful?
Logic gates.
Because of logic gates, and it's also because of certain logic gates are more native to certain types of designs. So if you can only have AND gates or NAND gates to be exact, can we convert negation, conjunction, and disjunction into just NAND gates? And the answer is yes. If you can only have NOR gates or the negated disjunction gate, can we convert all of the operators that we know into a NOR gate? And the answer is yes as well. Okay. I know it's not related to this class, but I just want to show you this. And this is the one thing about the way I teach classes is sometimes I just want to show you something that is related, but it's not in this class. I'm going to show you CISP 310 for this semester.
You just
I know there are two of them. I don't remember which one is the current one. Yep, it is this one. Okay. I just want to show you this because it is related. Low-level mechanisms and representation. Okay. It starts with a brief history of computer hardware. What is that?
Vacuum tube.
It's a vacuum tube, yes. Okay, and it's the component of certain computers, including the Colossus, which is the computer used to decode Enigma machine encryptions. Okay. Next up, we have transistors, smaller, more power efficient, but still kind of big. And then we have ICs or integrated circuits. And this is a projection of Moore's law about the density of transistors. And it's still going. We're still following that trajectory. This part tells you, a transistor is really just a valve. Okay. In other words, there's a control signal going into something, and there's a switch to turn on something or to turn off something. Okay. So I'm gonna skip all of this stuff here real fast. Two kinds of valve. We have active high and active low, and this is where I want to just kind of stop a little bit and not really talk about it a whole lot. I'm not going to test you on this one, but I think it is kind of important. This is a very simple schematic of 4 transistors, 2 input and 1 output. Okay. If you don't understand this part, don't worry about it. Okay. But some of you will see this again in your other classes. VCC is what we call a supply voltage. Okay, it's kind of like your battery voltage, the plus side, and this is ground, which is kind of like the negative side of your battery. Okay. T1 and T2 are input terminals. T3 is an output terminal. Q1 and Q2 are what we call P-channel MOSFETs. Now, P-channel MOSFETs are interesting because they are turned on when the input or the control voltage is low. The other 2 transistors, Q3 and Q4, are N-channel MOSFETs, and they are, the opposite. Okay, when the control signal is high, then it is turned on. Now, when I say turn on and turn off, it simply means the switch is closed. Okay, it completes the circuit. So when you look at this particular combination, what happens when T1, T2 are both low? Okay, if both of these are low, Q1 is going to turn on, it will close the circuit. Q2 will also close the circuit. Q3 is going to be turned off. Q4 is going to be turned off. So T3 will now have 2 paths to connect to VCC, which is a positive voltage. Okay? What happens when T1 is high and T2 is low? If T1 is high, this switch is going to be off, that switch is going to be on. When T2 is low, this switch is going to be on, that switch is going to be off. Now, when you look at the way Q3 and Q4 are arranged, they are arranged in series, which means in order for T3 to connect to ground, both Q3 and Q4 have to be turned on in order to be connected to ground. When you look at Q1 and Q2, those two are connected in parallel, which means if any one of those two is turned on, we have T3 connected to a positive voltage. Okay, so I'm not going to bore you with all the electronic stuff and whatnot. This is a NOR gate. It is a negated disjunction gate with two inputs. Now, why do you think this is somewhat relevant to what we just talked about? What if, go ahead.
The NOR gate acts as the processor's hardware level way of answering a NOR or a not statement in a program, isn't it?
It's more like the NOR gate is the basic Lego piece, okay? And your entire process is one big, huge, Lego construction, okay? So if the only piece, the smallest piece looks like this, then we better make sure that we can implement negation, we can implement conjunction, and we can implement non-negated disjunction, because those are the things that we are familiar with. So I'm not going to test you on this one.
The goal is to get to T3. The goal
is to get to T3.
In order to do that, if you want to, say you want to turn on both T1 and T2 in order to get to T3, and you have to be able to do negated OR statements to get to a conjunction.
Right. Well, basically the bottom line is this is a NOR gate, and this is the truth table of a NOR gate. So the question is, how mighty is a NOR gate? And the answer is, it is as mighty as a negation and a conjunction and a regular disjunction. Because I can use this little diagram to make a negation, because I just feed both inputs to a NOR gate from the same input. I can turn this into an AND gate. This is an AND gate implemented by 3 NOR gates. Have we seen anything like this? That's De Morgan's law. We just looked at it. And the last one is the non-negated OR gate. It simply needs a negation after the output of the first NOR gate. Okay. In other words, long story short, if I just have NOR gates with 2 inputs, I can implement all of the other gates. That's the bottom line. Now, why is that important?
It means you only have to design one type of gate to put in your processor.
Well, whichever type of gate is efficient from the transistor perspective, I can just implement that type of gate. So that's just a little digression, okay? But it is related to what we talked about in this class. Right, okay. It is impossible to know everything there is to know, or everything that is true. Now, why is that? It has to do with inference, or the way you can infer something. Okay, so I'll give you an example. If variable x has a value of 10 prior to an increment operation, it has a value of 11 after the increment. Does that make sense to you?
Yeah.
Okay. But that means there is an infinite number of truths, because the next one is going to be, if variable x has a value of 11 prior to x plus plus, then it has a value of 12 after x plus plus. So the number of truth statements is infinite, because we can infer one statement from another statement. It's an infinite series. Now, inference is also helpful in many other ways. Okay, in daily life, we also use inferencing a lot. So I'm going to use this as an example. Okay, so let's say Buymore sells a particular brand of computer called ROARC. I don't see anyone reacting to it, so you guys must not have watched Chuck. Okay, so this is the premise. Okay, a certain brand of computer, ROARC, is sold at Buymore. If Chuck comes to school with a ROARC computer, then you can deduce or infer from the premise that he or someone else must have bought it from Buymore, because that's the only place that sells ROARC computers. Is that making any sense? Let's look at the second one. Jack is severely allergic to dairy products. Okay, severely allergic means throwing up, spasm, and all kinds of bad things happen. But today he walks into the classroom without any issues. So what can you infer from that? That's Jack's evil twin.
He didn't really.
Well, the inference is he must not have been exposed to dairy products for the past few hours, because otherwise he'll be throwing up and not be normal. So we'll be doing a lot of this stuff, in this class, is to use a whole bunch of premises, and then use the premises to make inference. Yep.
Are we going to end up doing formal verification as well?
We are not going to do formal verification, but we'll talk about the tools to do that. Okay. So the next slide talks about bugs, vulnerabilities, and math. Now, why do you think those things are connected? Okay, the first one is a statement that many people claim and say, I don't need to know math to program. Okay, I hear that a lot from people from networking classes and from security classes.
What do you not need to know in a networking class? Are you kidding me?
Okay. So the real question is, how far can you go? How far can someone go without a whole lot of math background? That really is the question, because people can write programs without knowing much math. You can buy a book, right? You can buy a book, usually called Python for Dummies, or Learn Python in 24 hours, or something like that, right? And using that, you can put together a website with access to MySQL and all kinds of fancy stuff just by copying and pasting, or just load up the CD, copy the program, change a few things, and you have your website up and running. Go ahead.
You can do a lot of high-level programming without a lot of math background. The problem is that if you ever want to develop your own language or develop your own product, if you don't have a heavy math background, then you're not going to know what the hell you're doing.
That's one thing. Yep.
Or if you want to solve anything complex. Yeah.
Yep.
When in coding without a math background, and if you don't have the prerequisite skills to make the right checks, the right statements, the right loops, you can get errors in there that you don't even know how to process before you get even deeper. And the deeper you go with that error just sitting there that you don't see, the more your code over time can cause issue with whatever it is you're actually trying to do, and then you get lost trying to fix it.
Well, we all get lost either trying to fix something.
Eventually, yeah.
Okay, but the question is, why is it going to help? Why is math going to help? Okay, so we'll think about it a little bit here. How do you know that your program is correct? Okay, you're going to turn in your homework assignment. Okay, you're asked to do something, or you're asked to write a program that will do a certain thing. How do you know your program is going to get it done correctly? So, go ahead.
No, I'm just stretching, sorry.
Okay. So what most people would do is they will test the programs using test cases. So instead of just reading this stuff here, I'm just going to draw it on the whiteboard. It's just easier to see it in your class. So if you just look at this here as the entire space of all the possible input you can put into a particular program, okay? I would use blue to indicate the cases where your program is going to work correctly. So for the most part, your program is going to work correctly. Okay, so that's not blue. Okay, we'll use black. Okay, so the black part is the program, or the test cases where the program is going to work correctly. And I would use green dots to represent test cases where your program is going to break. Just a few. Okay. There we go. All right. So if you have this picture, then you can answer the question, your program is not correct, right? Because I can see there are green dots here where your test cases is not going to work out correctly. What if I am to cover this with a veil, with another sheet of paper? Then you cannot tell, right? So in that particular condition, when I put something over this sheet here, I give you some dots instead. So you can throw some dots onto here, and you can only see the color where your dart lands. Is that okay so far? So you can spot check. instead of looking at this whole picture and go like, oh, there are green dots, the program is not done. Okay, so you can throw dots at it. The question now is, what are the chances that one of your dots will fall on a green spot?
Very little.
Not a whole lot, right? And that's the problem of testing your programs using only test cases. And the other thing that I did not mention in my notes is, if you know about these green dots, or if you know where to put the dots already, at the green dots, you would not have put that programming mistake into the program in the first place, because you already know about it. Okay, so that is the limitation of spot checking programs by throwing dots. So what is the other approach to make sure that your program is correct? It's called code verification, or program verification. And this involves mathematically proving that your program is in fact correct. Okay. Are there any questions about that? But how do you prove that your program is correct? Well, the first thing is you have to state that what your program is supposed to do. That sounds a lot easier than it is. So I will start with this one here. A is an array. I want the outcome of a program to be a sorted array. I don't even care how you do it, okay? I just want you to express that the array is sorted at the end of the algorithm. So how do you know, how can you tell me that array A is already sorted?
Descending order.
Sorry?
Right, so sorted.
Well, let's say, in ascending order or non-decreasing.
You put various inputs in different orders and then check your output to make sure it's been sorted.
But how do I describe it mathematically?
You'd have to use some kind of a proof.
I'm not even proving it. I just want a statement that represents the correct output of the program. I'm not even proving it. I'm just saying what is considered a correct output.
A is sorted.
How do we express an array that is sorted? Let's take a look. This one is actually not as difficult as some of the other examples. Okay. So we have array A. Okay, let me just stop this a little bit. Here we go. Okay. So we have array A. So we can basically say, array A bracket 0, the element is less than or equal to A bracket 1, less than or equal to A bracket 2, and so on.
So then
Okay.
you'd want A n is less than or equal to A n plus 1 for all cases n.
Something like that, okay? But that's not the end of the story either, okay? If I give you an array of numbers to begin with, okay, and I say, go ahead and sort the array, and you say, oh, that's the requirement that I have to meet. That's an easy thing to do, right? How do I meet this requirement? The simplest program to meet this requirement is this, and so on. Because if all of the elements have a value of 0, they are naturally less than or equal to each other. I'm done with sorting. Is that sorting?
No.
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 Okay, if that is not sorting and it does not properly express the effect of sorting, what should I do?
Try to sort it.
Sorry?
Shouldn't you at least try to sort it?
No, I'm not even interested in how to sort. I just want to express what is correct, what is sorting something correctly. I just want to express it.
Well, to avoid that, you have to specify that the program is one-to-one. That is for every input, there's a specific output.
Yeah.
Every specific input.
In other words, if there's a 5, there's a 2, and then there's 1 in the original input, I need to have exactly the same values in the output. But in addition to that, the output also needs to meet this requirement. Okay, the first element has to be less than or equal to the second element. The second element has to be less than or equal to the third element, and so on. So this is what I meant. This is what I meant by it is more difficult than you think. Just to express the correct outcome is already difficult. Let's think of another one. Let's think about finding the maximum of something. Okay, so I'm just going to give you 3 variables: x, y, and z. How do we express z as the maximum Oh, can I use Z again? Let's use M as the maximum of the 3. Okay, sounds pretty easy, right?
But you have to, M has to be equal to one of the first initial input
That is the
values.
part that most people miss, okay? Because most people say, oh, it's easy to note or easy to express that M is the maximum of X, Y, and Z. This is what we need to do. You just have to say that M is greater than or equal to X, and M is greater than or equal to Y, and M is greater than or equal to Z, right?
What is M equal to?
But that does not capture the concept of maximum. It captures a part of it, but not all of it. Because if I am going to write an algorithm to solve this problem, to have this kind of outcome, it's easy. All I have to do is to say M equals to int max. Based on the representation of an integer, I just use a constant and say, this is the largest possible value that M can represent, and now it has to be greater than or equal to X, Y, and Z. But does that make M the maximum of the 3 variables?
Oh.
Nope, I'm missing something.
M is currently independent of the other 3 variables.
Exactly.
In order for it to be the maximum of one of the 3, it has to be equal to one of the 3.
Yep.
Not greater than or equal to, but actually.
So that means we have one more conjunction, but there's one more requirement, and inside that requirement we have 3 ORs. Right? Yep, go ahead.
You have the first part, and then you have the M, and then it says M equals X, M equals Y, or M equals Z. And not all 3 are equal to M, obviously. So the OR statements.
They can all be equal to M. I can give you 3, 3, and 3. The maximum of 3, 3, and 3 is 3.
Okay. Yeah.
But the correct definition looks like this. You cannot miss the last one because M has to be exactly the same as one of the 3. At least one of the 3 can be the same as all of the 3, but it has to be at least one of them. Is that making any sense?
Mm-hmm.
Now the question is, if we don't know how to express the correct output of a program, what are the chances that we can actually prove a program is correct?
0.
Very little.
In other words, if I cannot tell you the destination in coordinates or otherwise, what are the chances that we can actually get there?
0%.
Statistically? Do we want to do this right now, Tech?
But that's what we have been doing. Guess why we have all of these problems? Guess why we have Patch Tuesday, and today is Tuesday, right?
It's because that code has been layered on top of code that has bugs in it because it was never verified. And even if the upper layer of code has been verified, the bottom layers that it's supported by have bugs in them.
Yep, exactly. So that's why programming and math are closely related. Okay, I'm going to close today's. I'm going to end today's class with one more, comment. What do you think yoga or Tai Chi has to do with a sniper?
Breathing.
Breathing and
Concentration.
muscle control and concentration and stuff like that. Right? So it's the same thing here. Math is the same thing. Okay, it gives you all the training, so that when you are actually programming, you have the skill set to do it.
Symbolic logic, guys.
Symbolic logic. Yeah. We're gonna close the corner.
Why do they call it discrete structures and not discrete math? Where's the